Joining me on set is the news editor for ABC Science Online, Darren Osborne. Darren, can you just explain for us the events that led up to the development of this cyclone?
Well, in a way, if we look back at the floods that occurred in Queensland and southeast Queensland, it's pretty much the same trigger, and that's La Nina. And we knew about La Nina starting back in late June of last year when meteorologists started noticing that the warm waters of the South Pacific were starting to push up against the east coast of Australia. And when that starts to happen, you get a lot more warm water, you get a lot of evaporation, and so you get a lot more activity building up in the atmosphere. And so that La Nina event started to build up, and by the time we got to about October, we started to see a really strong level. We started to see that it was going to become one of the big La Nina events since we've been recording them. In fact, in December, the Southern Oscillation Index, which is a measure of air pressure between Darwin and Tahiti, it reached 27, which was one of the highest ever recorded. So we knew that there was going to be a lot of activity going on. The sea temperatures in the Coral Sea as well, off the coast of Australia, were also very high. So we knew that once again we had a lot of that sort of evaporation going on. And the Bureau of Meteorology late last year actually put out a note talking about their prediction of tropical cyclones occurring off the coast of Australia, and they actually predicted above normal activity, particularly for Western Australia and off the coast of Queensland. And certainly when you've got all those factors combining, that's when the cyclone begins to, those cyclones such as Yasi starts to take hold.
So it's fair enough when people start talking about all the crazy weather we've been having. It is all linked.
Yeah. I mean, it's when you talk about the origins of a cyclone. I mean, some people say it's caused by a butterfly flapping its wings on the other side of the world, and I mean, it must have been a very big butterfly that started this one. But certainly, when you have a combination of all those factors, you certainly end up with a lot more activity. In this case, Yasi too, by the way, it started on the 26th of January as a low pressure system off the coast of Vanuatu, and it took a couple of days to build up, and by about the 30th of January, that's when meteorologists knew that this was going to be a big one. And it was because there were no winds deviating it off course, it was being pushed by those easterly winds towards the Queensland coast, and it was certainly built up a lot of speed. And it is, as we heard a bit earlier, probably one of the most powerful cyclones we've seen in at least 100 years.
Well, let's talk a little bit about its effects. Why is most of the damage and the heavy rain that it's brought, why is that in that Townsville area and south of where the eye across the coast?
Yeah, look, it's a very, very interesting feature about cyclones. I know when I was watching it last night on the storm radar on the Bureau of Meteorology's website, I noticed that Cairns was not getting anywhere near as much wind or as much rain as Townsville, and that's because in the southern hemisphere, when cyclones are rotating around, most of the activity is occurring on the left-hand side as it's travelling, and the front side, and that's because those winds are swinging around from behind, around the left-hand side of the eye, and then around the front. And with all that, most of that activity occurs in that sort of quarter of the cyclone. So as it crossed the coast, in this case, we had the southern part of the cyclone and the front part, or the western part of the cyclone, where most of the activity was occurring. Also, by the time the winds swung around towards Cairns, a lot of that rain had fallen out of the sky. The winds had also been slowed down because of the friction of the ground as it passed over land, and so we're still seeing that even now with the eye of the cyclone well past the coastline. We're still seeing very heavy falls between the areas of, say, Tully down to Townsville, and hence the flash flood warning for Ingham.
Okay, Darren, thanks very much for filling us in on that. That's Darren Osborne, the ABC Science Online news editor.